We just looked at toilet paper time, and you could see that complex life on Earth has been here for a very short period of time when you look at the whole continuum of 4.5 billion years. So if we think about how it's been happened and it has changed, we know that there have been dramatic changes. There have been changes in life. There's been changes in the placement of the continents. Were they one? Were they two? Have they broken apart? Have they come back together? Have they built mountains? Has there been volcanic action? And scientists have looked at the evidence for the geological events and the biological events and divided Earth into chunks. So geological time, and the chart that you have, that is a man-made constraint by paleontologists to try to organize what has happened. Shells are always found in oldest layers. Eons are the longest division of time, and if you notice on your geologic time chart, there were 3 eons at the beginning in that molten magma, snowball Earth, very little life time period. The Hadean, where it was like hell, Hades, that would have been when it was truly molten. The Proterozoic, where your oldest known fossils, first life is. And then Archean, which just means ancient. Again, single-celled life, but a few more fossils from that time period. And all of that is lumped together and often called just Precambrian time or the Precambrian age. Then, all the rest of time, the Paleozoic, the Mesozoic, and the Cenozoic are known as the Phanerozoic eon. Then we have eras. And eras are longer spans of time, and they're based on the type of life that was dominant. So in the Paleozoic, which means ancient life, the dominant life forms lived in the sea. It was marine invertebrates. So the shelled animals, out of backbone, trilobite being one of the index fossils of that time period. And then Mesozoic, middle life, we had the large dinosaurs being the dominant species, often called the age of reptiles, though that is a name that's used in era because we now think that dinosaurs were not actually reptiles because they were warm and cold-blooded, so they're probably closer to birds than they were to any other species that's still on the earth, which is very interesting to me. And then Cenozoic is the present epoch, and it is dominated by mammals, the age of mammals. Periods are shorter time spans within the era, and they're based on what was going on in the crust. So, what was the plate action? Were the continents moving? Was it mountain building? Was it sediments being laid down, such as the Cretaceous period is named for the English chalk beds that were laid down at that time. And then epochs, you only see epochs on your chart in the Cenozoic era, and that's because so much was happening, and the fossil record is much more rich and deep and diverse in that time period, so it can be broken into even smaller amount of times. And you'll notice there are 7 epochs within the Cenozoic era. Now, early Earth, we saw on how the Earth was made, and they talked a little bit about it in Crash Course yesterday, but the Earth would have begun as a mass of dust, rock, and ice. Gravity bound this mass together, and more rock and ice struck it. Comets, meteors would have struck that mass, and it increased its thermal energy because the speed at which that was happening. It got hotter and hotter. The densest materials would have sank to the middle. That would have been our iron core. And space is so cold that everything else would have, all of that molten rock mass would have frozen because of the lack of temperature in outer space. So it hardened into what we have as the crust. The molten layer stayed between the crust and that iron core. In the Precambrian age, the atmosphere and the oceans would have formed. Rocks on the surface cooled. We have large land masses. That first land mass we called Rodinia. The oldest fossils that date back to this time would have been single-celled organisms present to our present-day bacteria. They would have been in the Archaean bacteria. If you remember, that is a separate kingdom. They're the ones that can survive very extreme circumstances, whether it's extreme heat or extreme cold. So they're the ancestors of the bacteria we find now today in the desert and in the holes. As organisms begin to use the sun's energy to make food, photosynthesis, oxygen in the air increases because that's the waste product of photosynthesis. We get our dense ozone layer in the atmosphere, and then when you have that dense ozone layer and that's readily available supply of oxygen, animals can live on land. They're not just required to live in the ocean to be able to carry out respiration. So life could become more complex as oxygen became available. The early Earth, again, was primarily oceans. So marine invertebrates are the oldest animal fossils that are found, and we've seen many pictures of the trilobites and amylocaris and some of those very shelled and fierce-looking sea life. As the seas receded and more land is above the surface of the ocean, that's when amphibian fossils are found, which are animal life that can live in the water and on the land. And that is where we'll start today, and we're going to do some markings on your chart. So I'm going to give you a highlighter, and then Monday we'll start with natural selection, and we've got some labs to do.